Hey everyone, and welcome to This Explainer. Today, we're diving headfirst into something we literally rely on every single day, yet kind of rarely think about. We're going to demystify the invisible infrastructure of the internet. By the time we wrap up here, you're going to have a crystal clear picture of the massive, hidden system that's quietly powering our entire digital lives.
So, what actually happens when you hit enter on a web address? It's a beautifully simple action, right? You type a URL, smack that enter key, and boom, a web page appears almost instantly. But in those few milliseconds, wow, your data just traveled thousands of miles across a wild web of physical wires and invisible protocols. To really get how that works, we're going to take a top-down, micro journey, traveling from that simple, everyday click all the way down to the physical wires, pushing those ones and zeros.
Okay, let's dive right into this. We've broken everything down into 5 clear, manageable pieces for our agenda today. 1. The network blueprint. 2. How data travels. 3. The OSI protocol stack. 4. Services and the DNS. And finally, 5. The stack in action.
Moving right along to Section 1, the network blueprint. To understand the micro details, we first need a macroscopic roadmap of the entire ecosystem.
And this brilliantly illustrates how it all fits together. Tracing the architecture from left to right, we kick things off with the absolute most fundamental units of data transit, packets and switching. From there, it flows right into the structural rules governing all this network communication, the layers and protocols. The strict rules that dictate exactly how distinct devices negotiate and connect, basically peer-to-peer architecture. And ultimately, that entire complex foundation exists for one reason, to support the right side of the ecosystem, the top-level user applications and experiences, like the services and multimedia we interact with every single day. Every piece literally builds upon the last.
Section 2. How data travels. Let's shrink down and look at the actual mechanics of movement here. So when you send data over the internet, it isn't just sent as one massive chunk. No way. It's broken down into what we call packets. A packet is your core unit of data routed between an origin and a destination. Just look at its anatomy. Think of the origin and destination headers exactly like the outside of an envelope. They hold the to and from addresses. And nestled safely inside those headers, that's your payload, the actual data. The payload is the letter inside the envelope.
Now, what's really interesting about this is how these packets actually move across the network. It's a process called packet switching, and it's basically the engine of the internet. You see, the internet is a connectionless network. That means when node A wants to send a message to node B, it doesn't just lock down one single static pipeline. Instead, it's like taking a million postcards, tossing them all into the postal system, and letting each individual postcard independently find the absolute most efficient, dynamic mail route to its destination. This maximizes efficiency and guarantees that if one path suddenly gets blocked, the packets just instantly route around it.
Now, contrast that with circuit switching. If packet switching is dynamic, circuit switching is entirely dedicated. Think of old-school telephone operators literally plugging physical wires into a switchboard to connect two people. In this traditional model, which was allocated for things like standard voice phone calls, you reserve a dedicated pipeline for the absolute entire duration of your connection. Nobody else can use that specific path while you're on it. A side-by-side comparison really drives the differences home. Packet switching is connectionless. It relies on those dynamic, independent routes, which means network resources can be super efficiently shared. That's exactly why it's the perfect primary architecture for internet data transmission. Circuit switching, on the flip side, demands a dedicated path where resources are completely tied up and reserved until the connection fully ends. The internet absolutely relies on dynamic resource sharing rather than locked paths, because otherwise there's no way it could serve billions of users simultaneously without instantly running out of capacity.
All right, Section 3, the OSI protocol stack. Let's talk about the standardized framework that actually makes this possible.
So, the crucial point is that the Open Systems Interconnection, or OSI model, provides the strict, universal language for data transit. This standardized framework dictates exactly how totally different networking systems can actually communicate with each other. It's a 7-layer architecture, starting all the way up at the user-facing top layer, the application layer, and moving all the way down to the absolute bottom, the physical layer.
Let's look at what actually happens to your data as it descends through those specific layers. It undergoes a literal transformation journey. When you send a picture or, an email, your rich user data starts up at the top, and as it moves down that protocol stack from your host computer toward the physical wire, the payload actually morphs and shrinks.
Here's how that shrinking process plays out. Your rich data is first chopped down into manageable segments. From there, addressing is added to turn those segments into packets. Those packets then get wrapped up into structured physical frames. And finally, at the very bottom layer, the whole shebang is transformed into pure streams of bits, just ones and zeros pulsing across a wire or flying through the air.
Now, here is a brilliant revelation about how these devices actually interact. Visually, it often seems like the application layer on device A is talking directly horizontally to the application layer on device B through virtual peer-to-peer protocols. They seem to have these nice horizontal conversations. But actually, scratch that. The hard truth is that real data always travels vertically. It goes straight down the stack of device A, shoots across the actual physical intermediate nodes, like routers on the wire, and then climbs straight back up the stack of device B to be completely reassembled.
Okay, Section 4, Services and the DNS. Let's shift our focus back up to the top-level user apps. So, what exactly is a network service anyway? Well, simply put, it's an application running at the network application layer and above. It handles the big stuff: data storage, manipulation, presentation, and communication. And it does all this by using client-server or peer-to-peer architectures that operate entirely on top of that invisible infrastructure we just decoded. Let's move to the next step and see how this builds our daily digital lives. We're talking about the World Wide Web, email, online gaming, video on demand, file sharing, the works. These user-facing services sit comfortably right at the very top of the OSI model we just explored, and they rely completely on that complex packet switching infrastructure down below to deliver all those seamless multimedia experiences we expect.
But hold on, how does a human typing actual words connect to these purely machine-driven services? Well, this is where the domain name system, or DNS, saves the day. Think of it as the internet's master phone book. You type a human-readable website name, a DNS server brilliantly translates that intent into a machine-readable IP address, and your computer connects. Without it, you'd have to memorize a random string of numbers for literally every single website you want to visit. No thank you. It elegantly bridges the gap between what makes sense to our brains and what makes sense to the network layers.
Which brings us to Section 5, the stack in action. Time to see all these moving parts functioning together in a single action.
This is the ultimate climax of our journey right here. It all starts with the trigger, you, the user, requesting data. That request hits the rules, traveling straight down the OSI model to morph into segments and frames. Next up is the package, encapsulating that data into addressed packets, which then take the journey across the global grid via independent packet switching. And finally, reassembly. The packets arrive at the destination, negotiating their way right back up the layers to present you with a flawless, seamless web page. It's like a giant puzzle coming together instantly.
We've covered some absolutely incredible ground today. We started with a simple click and uncovered this massive, invisible, highly structured universe of dynamic switching and strict protocols. Knowing that this massive, invisible complexity is happening millions of times a second right under your fingertips, flawlessly translating your human intent into global data transit, well, how does it change the way you see the internet? I really hope you leave this explainer deeply appreciative of the hidden infrastructure powering our world and super eager to keep exploring. Thanks so much for hanging out and learning with me today.